All right. So we started to talk about electromagnetic waves last week, and we're going to do it more formally and talk about general concepts involving light and photons, which is sort of the beginning of our ideas about quantum mechanics and atomic physics. So we'll start with the early ideas about light, the corpuscle and wave theories, and how the speed of light was determined. And then review what we mean by light as an electromagnetic wave. Talk about the Maxwell equations, Hertz experiment, and then an experiment which demonstrates that light really must be a quantum phenomenon, the photoelectric effect. And then talk about photons as the solution to that theoretical problem. Now, Isaac Newton wrote two really voluminous books on physics. One is Principia Mathematica, which was about classical mechanics, contained within it a derivation of calculus itself. But he also wrote a book on light, and that was called Optics, spelled in the style of 300 years ago, published in 1704. Now, I don't think I can do the English of the time justice by reading it to you. But the basic idea that Newton had was that light itself was somehow formed or created by the vibration of the parts of physical bodies, which was a pretty good guess, considering what experiment could he do to know such a thing. Now, there were differences of opinion on exactly what the true nature of light was. Christian Huygens wrote a treatise a little bit earlier, 1690, in which he laid out his basic ideas, including that it's inconceivable to doubt that light consists in the motion of some sort of matter. And now there's no doubt at all that light also comes from the luminous body to our eyes by some movement impressed upon the matter which is between the two. Here he's talking about what later became known as the luminiferous ether. We see waves, for example, on the surface of water, right? Water is the medium for that wave. Huygens thought that light itself must be a wave and that it must travel through some medium that was moving or vibrating. It's a little bit different from what Newton said on the previous slide. And then Huygens went on to enunciate his, what we call Huygens' principle, that consequently light spreads as sound does by spherical surfaces and waves, for I call them waves for their resemblance, blah, 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 and which represent a successive spreading as circles. So in a two-dimensional surface, we would have circular waves. In 3 dimensions, according to Huygens' principle, we have these 3-dimensional spherical surfaces emanating out from a point disturbance. We've used this when we first talked about waves earlier this quarter. But this is a new idea, that light itself must have something to travel through. Well, Newton and Huygens got into quite a debate about this at the time. And Newton eventually won the day. In his treatise Optics, he described the experiment that he did where he took a beam of white light, sent it into a prism where it was refracted, of course. And if you look at the light coming out on the other side, it's split into different colors, the colors of the rainbow. Blue light being refracted more strongly than red light. Okay? We know what's happening. In a glass prism, the index of refraction is higher for blue light than it is for red light. There's a frequency dependence or a wavelength dependence on that. But what Newton did is to take a lens, recombine those colors back into a prism, and send it back out as a solid white beam of light the way it came. And what he concluded from this is that light must consist of corpuscles, as he called them, or particles, and some property of the particles themselves gave those particles the color that they carried. And only when they were combined together, mixed together, did you get white light. White light was, there were no white corpuscles. There were just all the different colored corpuscles that were mixed together to form white light. And he thought there was no way to explain this with the wave theory. Well, let's think about the difference between the wave theory and the particle theory in a clicker question here. And you will need to talk to each other for sure about this. Which of the following properties of light is hardest to explain with the corpuscle or particle theory? A, that light rays travel in a straight line. B, the angle of incidence from a flat mirror equals the angle of reflection. C, light rays are bent or refracted upon entering a solid medium. D, solid objects cast well-defined shadows. Or E, that white light can be separated into a spectrum of colors. So one of these things, or maybe more, are very difficult to explain with a corpuscle theory. Discuss.